Good morning. I'm pleased to welcome you to our first webinar of 2025. My name is Rob Bertels. I teach at the Water and Wastewater Technology program at TRU and work with a team of experts on the Online Help Center for Small Water Systems. Before we begin, I wanted to do a traditional land acknowledgement and welcome. Thompson Rivers University campuses are on the traditional lands of the Tecumloops Secwepemc, which is the Kamloops campus, and the Tulk Williams Lake campus within the Secwepemc, the traditional and unceded territories of the Secwepemc. Thompson Rivers University, with their partners, hosts an annual webinar series of courses that are dedicated, webinars and courses that are dedicated to providing technical information, resources, tools, and for small water systems owners and operators and indigenous small water systems on issues of treatment, regulation, operations, maintenance, and water quality monitoring. The Online Help Center strives to assist all small water systems in BC to implement a multi-barrier approach to safe drinking water for systems to consistently provide safe, potable drinking water to their communities. The Online Help Center hosts webinars every 2 months in 2025, which are offered free of charge, and you can check out our website to see what webinars are coming up this year. For attendees who are EOCP certified operators, each webinar counts as 0.1 CEUs towards their certification. A certificate of completion will be issued after the webinar, and that can be presented to EOCP for your CEUs. We have a presentation, after the presentation is approximately 1 hour, and during the presentation, if you have questions, please jot them down in the questions section, and we'll address those questions after the presentation. So today's webinar, today we're looking at water quality monitoring, an introduction to water quality monitoring. And water quality monitoring is a legislative requirement for permitted water systems under the BC Drink Water Protection Act and Regulation. The presentation will provide an introduction to water quality monitoring of your small water system. It will focus on why it's important to monitor water quality, the legislative requirements, and best practices for operators and for the management of small water systems. Today we have Sylvia Wong, who's an environmental health officer with Interior Health. She is a specialist with their drinking water team. She's been working with Interior Health for approximately 12 years now and serves as a specialist to provide information and other services to both water suppliers, the public, and of course, drinking water officers. And Sylvia is going to cover today's topic on introduction to water quality monitoring. So I'd like to introduce Sylvia. And Sylvia, I am going to change the presentation to you so you have control and can provide the presentation.
Okay, thank you, Rob. Okay, can you see my presentation? Okay, I assume yes. Okay.
Yes,
so,
yes, we can.
Thank you. Thanks for the introduction, and thank you for joining me today on this webinar, Introduction to Drinking Water Quality Monitoring. So before we begin, I would like to gratefully acknowledge that I am calling in from the Secwepemc Nation in Salmon Arm. That's where I'm located. So here is just a very brief overview of today's webinar. First, we'll go over the importance of safe drinking water. Then we'll go over why water systems need to be monitored. Some of the legislative requirement, we'll go over briefly the water quality monitoring plan, as well as some common parameters to monitor, and then lastly, some best practices. So just a little bit background information. In BC, there are about 5,000 permitted water systems across the province. And within the Interior Health region, there are about 2,000 permitted water systems, and these include small water system, large water system, and the environmental health standalone systems. And about 1,400, about 70% of the water system are small water systems. So these are the systems that serve up to 500 population during any 24-hour period. So here's just a map of the interior health region coverage area. As you can see, it's quite a large area. And so in our drinking water program, we use a regional approach to supply services to the 2,000 permitted water systems. We have 6 environmental health officers in the small water system team. They are located in Williams Lake, Kamloops, Salmon Arm, Penticton, and Cranbrook. And we also have 4 specialist environmental health officers in the large water system teams, and they are located in Kamloops, Vernon, Kelowna, and Invermere. So these large water specialists, they provide support to large water systems that are serving more than 500 population during any 24-hour period. Also, we have the standalone systems, which are businesses such as restaurants with their own water systems that are inspected by our local area EHOs, and there are about 400 of those systems. And on this map here, this is from the Drinking Water for Everyone. This map shows all the 2,000 permitted water systems are within the interior health region. Some of you may have seen this website before. There's also, you can filter the system by water quality advisory, boil water notice, do not consume, and do not use. So systems that are on these notifications, you can filter them out by that. And this website do get updated regularly. So anytime when there's a notification posted, it will automatically update it on this website as well. So in general, trends have suggested that small water system may be more vulnerable to waterborne diseases outbreaks due to various factors such as climate change impact, limited financial resources, and regulatory compliance obstacles. And waterborne disease outbreaks in small water system are often a combination of issues combination of system failures. So on top of that, majority of the waterborne illness do go unreported. So you'll see 2 charts here. These are pulled from the BCCDC's reportable communicable disease dashboard. It shows, and they show an overview of giardiasis, also known as beaver fever, which is caused by giardia, as well as cryptosporidiosis, which is caused by cryptosporidium. And so this is the region selected is in BC. So giardia and cryptosporidium are enteric parasites that are commonly associated with waterborne diseases, and these parasites are assumed to be in most surface water sources and also higher risk groundwater sources such as shallow wells. So you can see in these charts that the annual rates for both giardiasis and cryptosporidiosis, both in BC, which is represented in the darker blue line, and then in Canada, which is the lighter blue line, you'll see that it's on the downward trend. And however, in 2019, you'll see there's a spike. And according to BCCDC, that is likely due to the change in the laboratory testing practices. So there's an increased sensitivity to the PCR tests for these parasites in 2019. So you'll see the spike, but overall you'll still see more of a downward trend for these diseases. And the general disease in the number of cases that we're seeing is partly due to the multi-barrier approach. Many of you probably have seen this diagram. In drinking water, we use the multi-barrier approach as the industry standard. The overall goal is to achieve the clean, safe, reliable drinking water, as shown in the middle in the water droplet there. So each layer is a different protective or preventative measure to help achieve safe drinking water. So the approach take all risks and threats into consideration and make sure there are multiple barriers in place to either eliminate the risk of threats or reduce the impact from these risk of threats. So it is a approach that utilize integrated system of procedures, processes, and tools to reduce the risk to public health. Because there's no single process or tool that can guarantee clean, safe, reliable drinking water. So the approach aimed to prevent and reduce the contamination of drinking water from source to tap. So as shown in the inner ring, you'll see there's the source, treatment, storage, and distribution. So source represents source protection, treatment indicate drinking water treatment, and as well as storage and distribution is the system storage and distribution system integrity. And then in the next layer, you'll see that there's monitoring, reporting, operations and management, as well as emergency management. So these are components that are necessary to support the core elements, so the source, treatment, storage, and distribution, to ensure that we achieve safe, reliable drinking water. So in this presentation, we'll be focusing on the monitoring and reporting component. So in BC, we all have roles and responsibilities in protecting the drinking water. So at the very top, you'll see the Ministry of Health. They are responsible for administering the act and regulation, as well as developing policy related to drinking water. And then the next box in the middle there, you'll see the health authorities. That's where we come in, the drinking water officers. So we are responsible for implementing and applying and enforcing the act and regulation and inspecting the water systems. And then in the last middle box, you'll see water system owners. And so as water system owners and operators, you're responsible for providing safe drinking water, as well as notifying the public and the drinking water officers about water quality issues. So ongoing monitoring is not only an important part of the multi-barrier approach as seen in the previous diagram, it's also a responsibility of the water system supplier, water system owners, in order to demonstrate good management and operation have occurred. Also that problems are being solved and identified and resolved and responded to quickly and efficiently to ensure that users are being provided with safe drinking water. And this also will help demonstrate the compliance with the Drinking Water Protection Act and regulation. So under the Drinking Water Protection Act, potable water is defined as water being provided by a domestic water system that meets the standards prescribed by regulation and is safe to drink and fit for domestic purposes without further treatment. So this is the goal that we're trying to achieve. Now we'll go into why a water system needs to be monitored. First of all, it provides information about your water source. So water quality and quantity fluctuates seasonally and is weather dependent. And it's based on any nearby land use activities like industrial, agricultural, recreational uses. So by monitoring, it provides useful data for the water supply to determine what treatment needs to be installed. And also, with monitoring, it provides information about your treated water. So it ensures that the drinking water is spectrologically and chemically safe to consume. It also ensures that the treatment system is working properly and performing as designed. So this will also increase water users' confidence in the operation. And also having written documentation will show users there's professional due diligence as water supplier. And performing monitoring helps identify problems and emergency quickly and efficiently. It reduces the duration of outages and minimize the frequency of system failures. Also, monitoring and maintenance may reduce the life cycles of system components and ensure that the drinking water is safe and reliable. It is also a requirement, as Bob mentioned, under the provincial legislation, which is the Drinking Water Protection Act and Drinking Water Protection Regulation, which we'll go into a little bit more later. But water suppliers are responsible for delivering safe drinking water that meets the requirements in the Act and the regulation, as well as the conditions that are set out in their operating permits. And these requirements could include like treating the water if that's necessary and ensuring water quality through monitoring. And also, it is the responsibility of the water supplier to notify the public and drinking water officers of any water quality issues as mentioned earlier. So the minimum monitoring requirements are prescribed in the Drinking Water Protection Act and the Drinking Water Protection Regulation. So the water system design should enable the water supplier to effectively demonstrate compliance and meet good industry practices. So under the Drinking Water Protection Act, Section 11, the water supplier must monitor its drinking water source, the water in its system, and the water it provides for the parameters and at the frequency established by the regulations and its operating permit. It also states that having the sampling required for that monitoring carried out in accordance with the regulations and the directions of the drinking water officer. And under the Drinking Water Protection Regulation, Section 8, it states that a water supplier must transport water samples to a laboratory in accordance with the procedures established by a drinking water officer. A water supplier must monitor for total coliform bacteria and E. coli at the frequency set out in Schedule B of this regulation. And a drinking water officer may establish different sampling frequency for a water supplier. So here you'll see the Schedule B under the Drinking Water Protection Regulation. This sets out the minimum frequency for bacterial water quality monitoring. So for water systems that are less than 5,000 population, the minimum requirement is 4 samples per month. And typically this is once a week, unless otherwise specified by your drinking water officer. And based on various factors for each water system, um, such as the risk of the water source, the drinking water source, the sampling history, the size and complexity of the treatment, the system itself, the treatment components, and whether it's a remote location, etc. The drinking water officer can vary the sampling frequency, and this can be done as part of the conditions on permit. So here in Section 8 of the Drinking Water Protection Act states that an environmental health officer can issue conditions on the operating permit of a water supply system, provided that the requirements are more stringent than what's in the Act and the regulation. So if there is a parameter of concerns, these conditions can make the monitoring more of a requirement, of a formal requirement. And with these conditions, it can act as a guidance for key for water supplier to focus on some of the key areas for water supply to focus on their water system improvement. So some examples of conditions can include monitoring a parameter of concern. So for example, turbidity, uranium, arsenic, manganese, fluoride, any chemical concerns associated with the water system that can be part of a condition to monitor. Also, another example could be installing continuous online monitoring of the disinfection concentration. That could be a condition. Also, another condition could be to creating and following a water quality monitoring plan. So we'll focus on this here. So first of all, what is a water quality monitoring plan? It is a detailed written plan tailored to each individual water system from the source to tap, and it aligns with the Drinking Water Protection Act and regulation. Also, the plan identifies key chemical, physical, and biological parameters to monitor. So if you have a baseline comprehensive chemical and physical analysis of your source water, together with the appropriate information and treatment protocol, you and your drinking water officer should be able to establish a monitoring plan that matches the water system needs based on these information. Also, the plan outlines the location, frequency, and how-to instructions for monitoring and as well as sampling. So overall, a water quality monitoring plan checks the effectiveness of the treatment and the integrity of the water supply system, as well as demonstrates and document the water quality of your water system. Also, the water quality monitoring plan depends on the type of water source. So if you have a surface water source versus a groundwater source, the monitoring plan could be very different. And also, if there's more than one source, each source should have should be included in the monitoring plan. And by reviewing the chemical, physical, bacteriological test results of the raw and treated water, any adverse or unacceptable test result can suggest that there's a need to look closely as to what the source of contaminants would be. So this is part of developing the monitoring plan. And also the plan would depend on the treatment component. So depending on the complexity of the treatment, there may be a more thorough inspection that is required for the monitoring plan. It also depends on the infrastructure agent type. So as you can see, the plan is very specific to each individual water system. The plan also includes record keeping. So it's great to monitor things, but it is also very important to record and write things down as part of the record keeping, because it is record keeping is the paper trail to show due diligence and can actually highlight when an issue is occurring, or if there is supply or demand issues that can probably be reflected in the monitoring. So part of the monitoring plan should include operations and maintenance procedure and plan, as well as treatment documentation. So chlorine residual log, for example. The water quality monitoring plan also includes reporting to water users. So it could be monthly and or annual reporting. So this depends on the type of system you have, but typically with system with permanent residents, it's a good idea to have at least annual reporting to keep water users updated on any upgrades or any issues regarding the water system and needing funding. So it also creates a great history for the water system in case you do have to transfer ownership of the water system or pass on operation to somebody else. So as mentioned earlier, in the multi-barrier approach, the key to ensuring clean, safe, and reliable drinking water is to understand the drinking water supply from source to tap. And this is also the same goal for a water quality monitoring plan. So when you're developing a water quality monitoring plan, think source to tap, what should be included in the plan, from the source through to the tap. I just have some examples where monitoring or documentation can be helpful in an investigation. So in one example, a water user complains about the color and taste of the water. And the water supplier can do a couple things to investigate the issue, check the system from source to tap if possible. Check the water intake for any signs of damage, check the treatment system to ensure it is functioning properly, check the turbidity or water clarity data, pressure within the distribution system, check the residual and the chlorine residual and chlorine demand. So in this situation, the water supply can also compare the information to records, any maintenance log that are available to see if there are any anomalies. So not only the water supplier can respond to the user in a timely manner, it also shows due diligence on the water supply parts by having documentation of the monitoring. And another example is an environmental health officer receives adverse sample results from a water system that's consistently showing low total coliform counts. So in this case, the water supply can perform a check of the system, again, from source to tap, and review their maintenance log to see if the issue can be identified, whether it is a treatment failure or they didn't notice there's maybe a pressure differential that maybe indicate that there's a break-in line causing consistent total coliform counts. So in this case, the detailed monitoring and maintenance log not only help with the investigation, but also shorten the time of response and allow the water supplier to bring the system back to normal operation in a timely fashion. So what should be included in the water quality monitoring plan, and what are some common parameters of interest in drinking water. So these would include biological or microbiological and chemical and physical parameters, which we'll go into details here. For biological parameters, they include bacteria, so E. coli, and protozoa, so Giardia and Cryptosporidium, and viruses, so for example, adenovirus. So pathogens are disease-causing microorganisms and primarily spread through feces. And pathogens can be naturally occurring in wildlife. They can get into water through nearby septic system or agricultural runoff. And so routine microbiological samples are required under the provincial legislation, as mentioned earlier. That's a 4 samples a month requirement. And these biological parameters are monitored through, we call the indicator organisms, and these are the E. coli and total coliform. We use indicator organism because there are thousands of different pathogens out there, and it's just not possible to test for every single pathogen. Also, the lab test may not be available for that specific pathogen or are complicated for some pathogens, which would make it very expensive to test. So the most cost-effective is to use indicators of fecal and environmental contamination, which are the E. coli and total coliform. And so total coliform is a bacterium naturally present in the environment. So you can find it in the surface water, soils, vegetation, decaying animals, etc. What the presence of total coliform does indicate the need for further investigation of source of contamination, and it can occur because of improper sampling procedure. Sometimes this is associated with low counts of total coliform, 1 or 2 total coliform. So in this case, oftentimes we have the water supplier resample. Some other causes could be inadequate malfunctioning treatment equipment, cross connections, or inadequate maintenance. So for example, biofilms within the distribution system. And in cases where there's presence of total coliform, public notification may or may not be required. As for E. coli, it's a bacterium found in the intestines of humans and warm-blooded animals. So it's not usually found naturally in the environment. And the presence of E. coli in drinking water does indicate that there's recent fecal contamination. So there is a greater risk that pathogens are present. So disease causing microorganisms are present. And so when you're seeing fecal coliforms or E. coli in your drinking water, it does represent significant public health threat, and boil water notice must be issued in this situation. And so when we're collecting bacteriological samples, it is being tested for total coliform and E. coli. So in Interior Health, we provide requisition forms to a water supplier. So here are some steps and tips to when you're collecting a bacteriological sample. On the requisition form, make sure you fill out all the necessary information, as well as on the sample bottle. Oftentimes, water suppliers or the water sampler forgets to write the information on the sample bottle. And so we oftentimes would get calls from the lab indicating, asking for confirmation. Also, another common issue we get is water sampler not writing the date or time correctly on the requisition form. So make sure that those are correctly written on the requisition form. And when you're submitting the water sample, ensure that it is submitted within the 30-hour time frame. So typically that's when you're after you collect the sample, it should be dropped off at the sample collection location as soon as possible, because it does take time to get transported to the lab. And sometimes if the samples are received more than the 30 hours after collection, the sample may be discarded or not tested. And it's always important to confirm the drop-off hours with your local office. Sometimes if the samples drop off late, they may not be shipped out. And once you receive the sample results, the sample results are posted on the Interior Health public website, and only the samples that are shown to be unacceptable or adverse, we would notify the water supplier. So all the acceptable samples will be posted on the Interior Health webpage. So at a minimum, drinking water needs to be treated to meet the Schedule A of the Drinking Water Protection Regulation, which specifies the bacteriological water quality standards for potable water. So under Schedule A, it states that E. coli, there should be no detectable E. coli per 100 ml of water tested. And for total coliform, if there's one sample in a 30-day period, there should be no detectable total coliform per 100 ml of water tested. And if there's more than one sample in a 30-day period, at least 90% of samples have no detectable total coliform bacteria per 100 ml of water tested, and no sample has more than 10 total coliform bacteria per 100 milliliter of water tested. And here you'll see the website where you can view your water sample results. And once you click, might be a little bit small to see, but here it says view drinking water samples. Once you click on that, you can search by your facility location, and the test sample results are posted for the last 120 days on this website. So if you are doing any kind of reporting to your water users, you may want to visit this website regularly to obtain the sample results that you can include in your monthly or annual reports to your users. And here is a list of the common physical, chemical parameters that should be tested for a new source. Often this is referred to the comprehensive chemical test, and this is what the environmental health officer use to complete part of the source evaluation for the source. So this list of chemical and physical parameters should be tested by an accredited lab. And you can find this list on the Interior Health webpage. So some of these parameters are health concerns, some are aesthetic, and some can be a concern for if you're installing treatment. So for example, if the water is showing high iron or calcium, it can reduce the effectiveness of the treatment equipment. And oftentimes the manufacturer of the treatment equipment has a maximum allowable concentration for these parameters in order for the equipment to meet the validated parameters. So that's something important to know. So if there is a chemical of concern, then it should be included in the water quality monitoring plan for the water system. And here it just shows an example of accredited labs in or near the Interior Health region. So we have the ALS Environmental located in Calgary, Kamloops, and Vancouver. There's also the Carroll Analytical Services Lab located in Kelowna and Richmond. And you can see the full list here as well. So Health Canada creates the guidelines for Canadian drinking water quality. And this is a living document. Changes are made on an ongoing basis because there are constantly research being conducted. So these values, these guidelines may change from time to time. So for parameters with health-based concern, uh, we have the maximum acceptable concentration, MAC or MAC. So these are when exposure to these contaminants could lead to adverse health effects in humans. And for parameters that are based on aesthetic consideration, they have aesthetic objective, AO, and these are chemicals that play a role in determining whether consumers will consider the water drinkable. So the taste or odor. And then lastly, we have parameters that are based on operational considerations. So these are parameters that may interfere with or impair a treatment process or technology if it exceeds the operational guideline. So for example, turbidity, if it exceeds the 1 NTU, it may interfere with chlorination or UV disinfection, for example. And here we have a list of some chemical parameters of concern that are commonly found in interior BC. So first we have the manganese. Manganese in 2019 has a revised aesthetic objective and a new maximum acceptable concentration. And manganese is essential in human diet, but in high levels in drinking water may increase the risk of um, um, brain development, harming the brain development in infants and young children. Um, and manganese is mostly easily absorbed in the body through drinking water. Also, next we have nitrates. So in high levels, it can cause blue baby syndrome, which reduces the amount of oxygen in the blood, reduce thyroid gland function in school-age children, and is a possible carcinogen. And next we have uranium. It could cause damage, kidney and bones due to direct toxic effect of uranium metal and may indicate that radon gas is also present. And then we have arsenic, which is classified as a carcinogen in the lung, the bladder, the liver, and the skin. High levels can cause abdominal pain, vomiting, diarrhea, pain and numbness to the extremities and muscles and weaknesses, and can cause warts on palms of hands or feet. Then we have fluoride at high concentration, can cause dental fluorosis in children, causing white, black, brown spots or streaks on the teeth. Then we have selenium at high concentration. It causes selenosis, so hair loss, tooth decay, muscle weakness, nail and skin anomalies, and neurological problems, and can cause garlic odor breath. So if there is a parameter of concern, you will be required to test more frequently. So for example, you may be required to do monthly arsenic testing for a year to gather the data and look for trends and seasonal changes and annual averages. And high levels of these chemicals may also lead to some sort of notification, could be water quality advisory or a do not consume advisory. So when collecting chemical samples, use bottles that are supplied by the accredited labs. There are specific bottles for each parameter type, and some of them do include preservatives. And it's the sampling procedure is very similar to the bacteriological sampling, similar to the packing and shipping. It should be following the instructions that are provided for the lab by the lab. And once you have the sample results, you compare to the maximum acceptable concentration, the AO aesthetic objective, the OG, which is the operational guideline listed in the guidelines for Canadian drinking water quality. And so some other parameters to monitor in a small water system can include turbidity, pH, temperature, pressure differential, disinfectant residuals such as chlorine residual, disinfection byproducts, UV dosage. These are all going to be dependent on your system. So these are something that you would consult with your drinking water officer, whether these are some of the parameters that need to be monitored, and these could be part of the conditions on the operating permit as well. And so for new systems, it is always a good idea to have a pilot study monitoring program. This will allow representative data to be collected and to demonstrate the operating conditions and treatment process performance under normal versus worst case operating conditions. This will help facilitate water quality monitoring design. So helps you kind of better plan what needs to be monitored for the system. And often these would include a complete raw water characterization, climate conditions during piloting, water quality parameters, and the associated sampling locations for each unit process being tested, the monitoring frequency for each parameter and the sampling location, as well as the monitoring equipment and calibration standards. And routine checks of all equipment and treatment components are ideal. So if you have a daily, weekly, monthly plan, that would help in kind of prioritizing what needs to be done at each visit. So that's why it's important to also have a routine schedule in place for checking the system and any treatment components. Water systems should have equipment to perform routine monitoring to ensure proper operation of the water system. So the monitoring equipment should be based on the characteristics of the raw water source and the complexity of the treatment process. And often testing and monitoring should be done by appropriately trained individuals. And so some of the monitoring equipment can include handheld turbidity meters that test for turbidity. And usually real-time turbidity is kind of what we're looking for. Pressure gauges that will check for pressure differential for filtration units. DPD method chlorine test equipment that tests for total and free chlorine. Also, pH meter may be required. So for bacteriological samples, when you're testing for total coliform and E. coli, typically the sampling site should include at the source, at the midpoint, or at the far end of the distribution system. So when you're determining location of monitoring, this is something to take into consideration. you want to select sampling site or location that are representative for the water system. So this is something that you can work with your drinking water officer to determine the best location for sampling. Also for chemical of concern, if that is something that needs to be tested, it should be monitored pre-treatment as well as post-treatment if treatment is available. And as always, this is something that you would consult with your drinking water officer as to where the monitoring should occur. And the monitoring frequency can vary depending on the risk of the water system, the sampling history, the size and the complexity, the level of treatment components. And so here are some of recommended frequencies for monitoring. So typically we want chlorine residuals to be monitored daily. If turbidity needs to be monitored, it should be daily. Visual inspection should be conducted daily. Routine chemical testing can be done every 3 to 5 years. And if there's any chemical parameter of concern, it could be done monthly, quarterly, or annually. And also, if there's treatment system in place to treat the chemical, then that would be something that you would discuss with the drinking water officer as to the number of sampling that needs to be submitted for that chemical. So as mentioned before, monitoring is important, but record keeping is just as important because it does create a permanent record of operation. You can always go back if there's an issue to review any of the data. Also, it demonstrates due diligence and professionalism, and it improves reporting to water users. By completing routine record keeping, you can include these information as part of your monthly or annual reporting. And it allows for, record keeping allows for continuity between operator handovers. If you have multiple operators, or sometimes there is an on-site operator, off-site operator, so it is good to have these record keeping in place. And here is just an example of the monitoring plan. Might be a little bit small to see, but the top we have filtration and storage tanks information. So if you have filtration and storage tank as part of your system, you may want to include this as part of your monitoring plan. You would include the date and time of the visit when you check the pressure, and you would indicate the pressure noted. Here, there's also space for a flow meter, reservoir level, and then it is always good practice to have initials, so who did the checks during that visit. And then we have the filter operations, UV operations, hypochlorinator operations. So depending on your system, depending on what equipment you have or what treatment you have, then you would have those as part of your monitoring plan. And then here, there's the chlorine readings and within the distribution system. So there's the free chlorine residual table, as well as the combined residual that you can document. Same, it's date and time of when you complete the monitoring, as well as the location would be important. And then there's the maintenance log in the middle box here, table here. This is when anytime you do any type of maintenance. So for example, during your visit, you complete a UV bulb replacement, you may, so you would indicate that in your maintenance log and document that. And then lastly, there's complaint log. So this would document any complaints that you received, and just document that and kind of provide what actions was taken in response to that complaint. And so, as mentioned before, there's monthly reporting, annual reporting that can be sent to the users. So with the monthly report, you can include the purpose of your visit. So whether it's a routine service or an emergency visit, and you would indicate all the monthly monitoring logs, include those. So the logs that are in the previous slides, you can include those, as well as any if there were any issues with that with the system during that month, you would indicate that in the report and just what was the actions taken. And then for annual report, you must contain results of all monitoring required by the legislation, the conditions on the operating permit, or if it's something that the drinking water officer requires. So it can also contain a, a brief summary of the water system, history of the water system, notices, so public notification of any threats to the water system. You would indicate that and the reason why. Whether there's any drinking water health hazards identified. Also, you can include a summarized version of your emergency response and contingency plan as part of your annual report. Um, Also, it is also beneficial to users to include treatment goals if there is more treatment that needs to be installed and kind of the plan moving forward. What is the plan? So these are just some examples of things that can be included in the annual report. So this presentation is a very brief kind of overview of an introduction to water quality monitoring of a small water system. There is a more detailed course available on the online help center. So if you haven't taken this course, it would be a course that is beneficial to water suppliers with small water system, as it goes into more details and provide templates and some of the monitoring requirements. So please don't hesitate to register for these courses. Here on the right side, you'll see the 2025 schedule for the course. So you can register for any of these courses. And here is just some guidance document that might be helpful that for your operation. So I have provided a slide here, and that concludes my presentation.
Thank you, Sylvia. That was a great presentation and really informative, and a really good introduction to water quality monitoring there. This is a time when we can take questions from our audience. So there's quite a few of you out there. If you have questions, type them in the chat and we'll do our best to answer those questions. Oh, wow. Okay, so we do have a question here, and it says, can you remind us of the difference between a DWO and an EHO?
Yes, so DWO is a drinking water officer, and an EHO is an environmental health officer. So EHO can be delegated as drinking water officer under the legislation. So we use them interchangeably, especially in our program, because the EHOs and the drinking water programs are delegated drinking water officers as well.
Hmm.
Hope that
Okay.
answers the question.
I think it does. Yeah, I hope it does. Okay, so we have a question. Where do the water samples submitted to IHA get tested?
So the water gets, depending on where you're located, some of our samples get sent to Carroll for testing. Some samples get sent to BCCDC for testing. So most of our samples are through Carroll. Some of the East Kootenay systems get sent to BCCDC. So yeah, depending on where you're located, that's where the samples will get sent to the lab for testing.
Okay, we have another question here. It says, sometimes it takes a long time for sample results to appear on your website. Would it be possible to update right away?
Yeah, that would be ideal. Unfortunately, with how this system is is set up right now. Sometimes because it has to be manually entered by our admin, and sometimes depending on the workload, it could take a little bit of time. But if you're waiting for a result, don't hesitate to reach out to your drinking water officer or your environmental health officer, and they may be able to assist you and get the sample results for the sample that you recently submitted. So if you don't see it on the website, don't panic. You can always reach out to your environmental health officer or drinking water officer, and they will be able to assist.
And those are for bacteriological samples, not chemical samples, right?
Yes, just bacteriological. Yeah.
Okay. A long question here, 1 second. Says, where can I find the basic troubleshooting table on EHO examples? Who do I contact for archived results? And the timeline I am reporting on is longer than 120 days, so the website will not show results, correct? That's a question mark.
Okay. So first question, where can I find the basic troubleshooting? So it this because the scenario can be very different for each water system. There isn't really a basic troubleshooting table, but you can always, we're, as a mental health officer, drinking water officer, we're here to assist. So if you're experiencing any issues with your system, you can always consult with your drinking water officer. Also, alternatively, you can reach out to any drinking water companies that, if it's something to do with the treatment, you may reach out to those companies that can assist. Alternatively, you have qualified professional that may be able to assist with some of the issues that you may be experiencing. So it really varies. There isn't really a cheat sheet for any of the issues. But yeah, there's always, we're always here to assist. And if we don't know, we can always provide resources as needed. And then second question was, how do I contact for archive samples results?
Yeah.
So you can connect with your drinking water officer, and sometimes I believe there is a cost associated with the obtaining archive sample results, but check with your drinking water officer. They may be to pull up all the archive results for you. And in terms of the timeline for on the website, yes, 120 days is how long they will post the sample results for. So it is good practice to go on the website regularly. And what a lot of my operators do is they screenshot the web page so that they have those information for when they do need to report out to their users of their bacteriological monitoring quality for that month, or for example.
Okay.
Hope that answered all the questions.
That was a long question series there, but it was good, good. So do the West Kootenays have a drinking water officer?
At this time, we don't, but all the if there's any question, we do have an intake box, a duty intake box that you can send any questions to. So unfortunately, we don't at this time, but hopefully soon we'll have someone in the West Kootenay. But I'm sure the area will be notified if once we have an area EHO there.
Okay, good stuff. All right, where do we find a comprehensive list of larger sample testing available ppm? I'm assuming this is a comprehensive list of parameters, I'm assuming. And the person here states that never found it online anywhere, and would like to look at things like lead and arsenic.
So there is a list on the Interior Health website, and I can probably include that in the presentation because the presentation will be posted. There's a link on the Interior Health public website where there's a list of parameters for news sources. So on there, you'll find the list that I presented on the presentation here.
Yeah, I do believe the guidelines for Canadian drinking water quality also carry the comprehensive list and the potential health effects associated with any particular parameter that's listed.
Yes, yeah. That's another good source to go to.
That's a great resource, that one. Okay. We don't seem to have any more questions at this time. If you do have a question, please put it in the chat there. We'll try and answer it. We'll stay online for a few more minutes here. If you think of a question after this presentation is complete, just email the Online Help Center. We'll try and answer your question for you. We'll probably reach out to Sylvia here and ask any questions that are associated with the presentation, but or contact your drinking water officer provincially in BC. For people outside of BC, there are individuals that are regulators that act like drinking water officers. They have different titles, but they are water-specific professionals, and they could answer your questions as well. Okay, so another question here. Is there a standardized format for monthly and annual reports?
There's no standardized format, but there are templates available on the Online Help Center. So if you go to one of the tabs on the top on the Online Help Center, and then click on Monitoring and Reporting, there are examples of monthly annual reports that you can utilize. It is also in the Small Water System Guidebook as well. There's some templates there as well.
Okay, good stuff. If there are exceedances in chemical parameters, example, uranium, is it up to the drinking water officer to decide on a case-by-case basis how much of an exceedance for how long these exceedances are noted is considered acceptable?
So if it exceeds the MAC, then that is over. So typically there would be a monitoring program in place to see if this is a consistent or is it a one-time thing, or so this is something that you would work with your drinking water officer, and yes, it would be case by case depending on the situation and whether you're sometimes there is a source contamination associated with the chemical. So then, you know, if that source can be eliminated, then there might be better better idea of whether this is going to be an issue for the water system. So yes, this is something that would be in consultation with the drinking water officer.
Okay. Another question that's come in is when a bacteriological water result shows a value of 1 total coliform, should we issue a boil water advisory?
Depends, not necessarily, because sometimes it depends on the sampling history. If it's consistently we're seeing low counts like this, it may indicate that there is something that's going on with the distribution system. So at that time, we may issue notification. But if it's a one-time thing, it could be sampling error with low counts like this. So it really depends on the system and the history of the system. So this is something that the DWO will be able to provide further guidance on that.
Sounds like a conversation between the drink water officer and the operator at the time to see what's going on.
Mm-hmm.
All right, another question here. Can one water supplier operator access test results from other areas? I think it's from other water systems they're speaking about.
The water system. If it's bacteriological test results, then it's all on the Interior Health website. So it can be viewed on that website. So I don't know if it's for bacteriological or chemical. Yeah, so I'm not too sure to that question unless there's a bit more details.
Yeah, and you mentioned annual reports there. Sometimes test results are found in annual reports, aren't they?
Yeah, so yeah, if the water system provides annual reports, then there might be information there that that is posted on the water system website or something like that. So
okay. I have another question here. Is it possible to test in-house? Is there a cost for consumables for this, etc.? I think what the question actually is there a possibility for a water supplier to set up their own lab? I'm assuming that's the actual question there.
yeah, there are some larger water systems that have their own accredited labs. So the key is that yeah, unless it's accredited, we won't be able to test the sample from that lab. But if the lab gets accredited, then that is a possibility.
And I do know that the BC government provides a list of accredited bacteriological labs, don't they?
Yes, they do. Yeah.
Okay.
Yeah.
Is the water quality monitoring plan a requirement or only necessary if our EHO requests it?
So the plan itself, it's not required in the legislation, but the monitoring is. So oftentimes that's what the drinking water officer would require a plan in place. So because otherwise it's hard to track, okay, what do you need to monitor? Because monitoring is part of the requirement under just the legislation. So yeah, so it makes sense to have a plan for monitoring.
Well, you may know the answer to this question. It's a little bit off topic with regards to water monitoring, but it has been asked, is a public health engineer, I'm assuming this is a construction permit, required for system upgrades for new UV, new filter housings, or is this considered regular maintenance? I think it's with regards to replacement of components.
Yeah. So if it's replacement, if it's like for like, then CP may be waived, but still a construction permit application will still have to be submitted to a public health engineer. If it's a new treatment, new system, definitely a construction permit application will have to be submitted to our public health engineering in order to receive a construction permit for the construction to happen.
Another question that's just come in, it says, do you recommend any pressure transducers to monitor water quantity change in groundwater wells?
That I'm not very familiar because that's more related to the groundwater wells. So I'm not too sure about that. That might be something that I have to get back.
And I think that may be a requirement with the groundwater officers in BC, but it really would be system specific. So maybe
Yeah,
the water suppliers could reach out to the groundwater officers to ask that question.
yeah, I think that's a good idea.
All right, are monitoring form templates that you showed available to download?
Yes, so actually, if you take there are some templates on the Online Help Center, but also through the water quality monitoring course, the detailed one that I just showed in the last slide, there will be templates available. It will be provided through the course there.
Okay. Another question has just come in, and this is not in the scope of small water system management, but can private home sources get free testing, as well as for things like Giardia included in the IHA umbrella, or is that not a concern to IH? The question does go on here. I'll just complete answering it. If they obtain the results privately, should they be compelled to share with Interior Health primary surface source sampling?
So what I'm understanding is private user sampling, whether it can be done through Interior Health. Is that?
I believe that's the scope of the question, yeah.
Yeah, we don't typically do private sampling. All of the sampling we done are for permitted water systems only. So so private users will have to do their own sampling. Yeah.
Okay. We'll just wait a couple of minutes here to see if any additional questions come in.
Sure.
I'm not seeing any additional questions coming in at this point in time. Oh, there is one comment here. It says certificates for today's presentation will go to the email you used to register and attend today's webinar within 24 hours. So this is for our EOCP certified operators who have attended today. They can get their EOCP certificates from us at the email address that they registered with. You take those certificates and you apply them to your EOCP credits. If you're having trouble with the CRM for EOCP, contact EOCP. They're a great bunch and they're very helpful with their operators. And also the presentation and video for this presentation will be posted on our website by our staff here. And so you can review this information at a later date. Certificates wouldn't be, of course, provided for operators who view at a later date. It's just can't be done, unfortunately. And I just want to thank everybody for attending today. And we will be having future presentations. Please check back on our website. And also just a quick note, our website is always changing with updated information. So check into the website frequently and you'll find additional information. I want to thank everybody today for attending. And I want to thank Sylvia for doing a great job with her presentation today. Thank you.
Thank you. Bye.